So, good morning, my dear students. Welcome back again to the channel. This side, your chemistry mentor Govind sir, and today again we are having a new video, lecture number 4 for thermodynamics. Till the lecture number 3, we have completed the concept of heat. Now we are going to discuss about the energy. So, children, energy exchange. During the thermodynamics process, I told you energy can be exchanged by two ways. Yes, sir, you told me. What are the two ways? These are the two ways. Number one, in the form of work. If work in the form of work energy is exchanged, then it will be mechanical. And in the form of heat. So heat we have already discussed, which is non-mechanical. So let's focus on the work. What is work, children? So you can say mechanical way work is a mechanical way of transfer of energy. It's a mechanical way of transfer of energy. Okay, so this is the concept here. In that case, we are going to discuss about the work, mechanical way of transfer of energy. Okay, what it is? It's a mechanical way transfer of energy. What formula you know for the work? W is equal to F into D, displacement. What formula for electrical work? Is equal to Q into V. Gravitational work, mgh. Spring, work of spring. There are so many formula. So these formula from the physics I told you, but here the formula which we used for the mechanical work of gas is equal to minus P external delta V. So external means external pressure, delta V means change in volume, okay. So this is the formula. Now you have to think about it. So what is W now? W is equal to minus P external delta V. Suppose children, in any container, this is a vessel, and in this vessel gas is filled. After that, one piston is applied. So from this side, pressure of gas, and it is your external pressure. Okay, so there are two cases. Case number one, if gas expand means volume increases. Here see, if gas expand, that means volume increases. If volume increases, then what is delta V? Delta V will be positive, so work will be negative. If gas expanded, then work will be negative. That means work done by the system, by the gas, you can say, not system, work done by the gas. Case number two, if gas compressed, then delta V, volume decreases, negative, so work will be positive. Then work done on the system, on the gas, because we are talking about gas. So these are the small things you have to focus on it. Okay, so this is about the things. If gas compressed, then volume increases. Sorry, gas expand, volume increases. Gas compressed, volume decreases, and work negative and positive will come. Let's talk about the derivation of this. Now I am removing it. So what formula we discussed? W is equal to minus P external delta V. If expansion is there, expansion of gas, so I told you delta V is equal to positive and work will be negative. Compression, then delta V negative and work will be positive. These two things you have to remember. So let's do the derivation. In the case of expansion, gas expand. So here vessel, in this vessel gas is filled, and then piston, this is your pressure external, and here you have gas. Okay, then so gas expand, then what happened? Gas volume expand. In that case, this is the condition of piston. Now this is your pressure external. See, so this volume increases, and this volume is delta x. What is this volume? Delta x. So what is the normal formula? Work done is equal to minus, because expansion, into displacement. What is F? Force. How to find? So here I am telling you, pressure is equal to F upon A, then F is equal to PA. So here you can use minus PA, and what is the displacement? This is the displacement, delta x. Yes or no? Now tell me, we are talking about this area. So what is this area? It will be like this. This is the area. In this area, what is the formula of volume? LBH. So LB is what? Area, that is A, which is this A, and H is height, and what is A into H, and what is the height here? This delta x. So it will be considered as minus P external. This is the external pressure, and delta V. So A into x, A into delta x, that will be your delta V, volume. So W is equal to P external into delta V. Any confusion? What I said? Area is what? This area increases, this much area, from here, this area. So area is equal to what? Length into breadth. And height, what is volume? LBH. So LB is given, area already A. Here if you are talking, then this will be the area, and here this is the area, and height is how much increases? Delta x. So A into delta x, what? Delta V, volume, and this formula derived. Okay, so one question we'll practice. A gas expands by 0.5 liter against on external pressure of 1 atm. Calculate the work done. So check it. Gas expand. So minus W is equal to minus P external delta V. So pressure is given 1 into 0.5. So it will be W is equal to 0.5 atm liter. You can convert it into joule also. How to convert joule? 1 atm liter is equal to 101.3 joule. By this value you can convert into the joule. Okay, and gas expanded, then in the case of expansion work is negative, so it is negative. Okay, this is the formula, that is the note, remember always. Now check it. Question number 2. One graph is given, pressure versus volume in liter and pressure in atm. Gases travel from here to here. This is point A, this is point B. Here volume is 1, here 2, and here 3. Here pressure is 2, then 4, and here it is 6. What's going on, children, here? Expansion of gas, yes or no? Yes, sir. A gas expand from A to B. Find the work done. So what formula? W is equal to P external delta V. So delta V you can find out, 3 minus 1, it will be 2. But here this pressure is applied when pressure is constant. So this formula you cannot use, because this pressure will work, this formula will work when pressure is constant. Then how to find, children? So how to find this kind of problem? For that we have to do something. What we have to do? Okay, so check it. Here again one graph, pressure versus volume, and the graph is like this. Okay, this line we have to increase. So how to solve, children? Here you have to choose a small strip of this gas expansion. This, take this out, a small strip. So volume will be dV, small volume represented as dV. So this is the small volume dV. This volume is dV. So what is the area of strip? Area of strip So length into breadth. So this is your length, this, and this is pressure. So P dV, and PdV is what, children? PdV is this work. So a small function. So dW is equal to PdV, because minus sign is there, that's why mod I am using. Then integration. So now this is your area of a strip, and that is the work done. So if you find the total area means, suppose this last point is V2 and this initial point is V1. So if we know the total area, then total work will be done. Find out total work done is equal to total area. See, for a small strip, this is the work done. Work done equal to total area of the strip. So total work done, if you want to find out, the total area. So W is equal to integration P dV from V1 to V2. That formula we have to use when variable pressure is given. So which formula we have to use? Here I am writing W is equal to P external dV when pressure is variable, and this is for constant pressure. So now you can find out W is equal to area. So what area it is covering? It is a trapezium. So area of trapezium 1 by 2 sum of parallel side, this and this. So 2 plus 4 and height, this will be the height. So it will be 2. So it is 6 atm liter, and gas expended, then it will be minus. That is the answer. Check it out properly. Sorry. So now I am removing it. If variable pressure is there, like that you can find out. So next question, more question we will solve. Sorry. Here point A to B, B to C, and C to A. This is 2, 4, 6, 1, 2, 3. This is volume and this is pressure. It is in liter. Pressure in atm. Question is, find work done Number 1, A to B, B to C, C to A, and A, B, C, A. 4 work we have to find out. So let's check it. WAB. AB. What area it is covering? No area, it's a single line. No area it is covering. So work done will be 0 because no area covered. B to C. This B to C. C. So B to C expansion. And what area it is covering? C. This area. It's a rectangle. So what work? Length into breadth, area of rectangle, length into breadth, 2 into 6. So it will be 12 atm liter. And expansion is there, then minus. W C to A, C to A, this one. So compression, and what area it is covering? This again trapezium, this area. So again 1 by 2, 2 plus 6 into 2. So 2 cancel, it is 8 atm liter. Compression, then positive. So last, W A to B, A B C A. So for that, for cyclic work, you have to add all these work. 0 plus 8 minus 12. You have to add. So I am again representing in proper way. It will be 0 plus minus 12, 12 plus 8. So it will be minus 4 atm liter. So this work is 0, children. It's a cyclic work. W cyclic. Here it is not equal to 0. Sorry, I put 0. It is not equal to 0. It's proof that work is a path function. Because in state function I told you, cyclic state function always they will be 0 because they depends upon the final and initial condition. I hope it is clear. Or you can find out this WAC is equal to area of cycle. That is the direct formula for cyclic work. So area of that triangle. Remember always, if clockwise, then W will be negative. If anti-clockwise, then W will be positive. This thing you have to remember. So that is it about the today's lecture, children. Remaining question we will solve in the next question, and next topic also we will cover there. So once again I am requesting, subscribe the channel, watch the video more. It will help me and it will encourage me also.